Hello, geometry students doing the distance practice questions. I'm going to go through the odd ones with you and taking a look at this first one, question 1. Use the number line to find JK. So we're going to go JK and we're just going to count 1, 2, 3 units. And so that would be 3 right there. So for number 1, we'd have 3. I'm going to go ahead and do number 2 also, and I'll do all the even ones actually. I'm not going to do the odd ones because I think you have access to odd ones somewhere, so that's why I'm trying to do the ones you don't have access to in case you need help with them. Okay, use the number line to find NP. So NP, let's look at NP. So NP, we're going to go 1, 2 places. So we have 2 there. I'm going to go down to number 4. That's all we do. Pretty simple. Number 4, use the number line to find LK. So LK, I'm looking at LK, and still LK, we have 2 units. That's the difference between them. That's the distance between them. So LK is going to be 2. For number 6, LF, so we're going to look at L and F. And so the difference between those, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you should have 14 for LF, and that's question 6, 14, yeah, okay. Want to make sure. And you know, they're trying to see if you understand, you know, the distance between, you know, even if you're going forwards or backwards on a number line, you're just trying to find how long that is. So you're just counting the units in between those. Okay, so let's go to number 8. Number 8, determine whether BD and DF are congruent. So BD was 1, 2, 3, 4, 5, 6, 7, 8. And then DF are 1, 2, 3, 4, 5, 6, 7, 8. So yes, 8 equals 8. So yes, they are equal. They are congruent, same length. 10, CD and DF. So CD is 1, 2, 3, 4, 5, 6. DF is 1, 2, 3, 4, 5, 6, 7, 8. So 6 and 8, we have a length of 6, we have an 8, so no, they are not congruent. For number 12, find the distance between A and N, and if A is at 2, 6, and if N is at 5, 10. Now, I'm assuming that you guys are going to go over the distance formula. So the distance formula I have written right here, where the distance equals the square root of your second x value minus your first x value squared, plus the second y value minus the first y value squared. Okay, I know that looks ugly, but it's actually pretty simple. We have, you know, our first x and y coordinates and our second x and y coordinates. We have 2, 6, and 5, 10. 2, 6, and 5, 10, right? So I just go ahead and label them, my x1, y1, my x2, y2, my first x and y, my second x and y. That's all that x1, y2, all that business means. And then I just plug those numbers into the problem. So my x2 is 5, so 5 goes here. Minus my x1 is 2, so that goes here, minus my x1. And I square it. And then I add the quantity of my y2 is 10, minus my y1, which is 6, and I square that. So I have 5 minus 2 is 3, and I got to square it. 10 minus 6 is 4, and I got to square it. So I have 9 plus 16, which is 25. Square root of 25 is 5. And remember that square root button on whatever calculator you're looking at is going to be looking like this. Even if you're using Desmos, you would be using that. And so to get to it on this calculator, I have to hit the second button. So you might, I think on your, your graphing calculators too, you have to hit the second button. And then, just plug it in. You don't have to put the back parentheses if you don't want. You could and still be the same answer, and it's 5. Okay, take a look at number 14. Hopefully you're pausing this as I move forward. A tiny songbird called the blackpoll warbler migrates each fall from North America. A tracking study showed one bird flew from Vermont at map coordinates 6345 to Venezuela to map coordinates 6710 in 3 days. If each map coordinate represents 75 kilometers, how far did the bird travel round to the nearest kilometer? So here's my x1, here's my y1. So x1, x1, y1, and here's my x2, y2. Okay, and I plug those in. I wrote it out here. Plug it into the distance formula, and then I just start working it out. I end up with 4 squared plus negative 35 squared. You could pause that to jot that down. Negative 35 squared is just negative 35 times negative 35, which gives you a positive 1,225. 4 squared is 16. You add those two, you get 1,241. Take the square root of that. You get some ugly like 35.23 something, and it goes on forever and ever. You multiply that by 75, which gives you 2,642 because it was each coordinate represents 75 kilometers. That's why I multiply by 75. So total that bird flew in 3 days. Wow, that's amazing. 2,642. Number 16. Going to number 16, just to wrap things up for this little video here. We're just finding the distance between m and n, and we have a negative 1 and 8 for my x1, y1. And for my x2, y2, I have my negative 3 and 3, round to the nearest tenth if necessary, and it will be necessary. So once again, x1, y1, x2, y2, and if you want to write this out, you can. This is the distance formula. I plug those numbers in. I end up getting negative 2 squared plus, that's a negative 5 squared. That's supposed to be a negative, sorry. And so negative 2 squared ends up being 4, negative 5 squared ends up being 25, so 25 plus 4 is 29. Square root of 29 ends up being about 5.4 units. So you're at 5.4 units for that one. Hopefully this was helpful, and if you need more help on this assignment, let me know.